Okay, hello. Today I'm going to present about the electric field that due to dipole. Okay, first talk about the dipole. What is the dipole? Um, Dipole is the object that inside have two charge inside. Okay, have charge positive and charge negative. So I will give an example. Object that have two charge inside are like H2O, the water, right? Water. The head are hydrogen. Hydrogen is positive. The charge is positive, and oxygen is negative. So when you got two charge inside, called dipole. And if you have two charge inside, you will get electric. Okay. So we talk about electric in dipole. Let's start with the theory. Okay, the formula of this method is vector E equal to E is represent of electric, okay, equal to 1 over 4 pi epsilon naught multiplied by Q is charge over by magnitude of vector R square multiplied by R hat, and R hat you can find by this one, vector R divided by magnitude of vector R. Oh, sorry. So you will got the new formula. Okay. Okay, before we go to the visualization one, talk about this picture first. Okay, like I already told, in one object you got two charge, right? Positive and negative, positive. And I will set one point that electric can go in red line and yellow line. Okay, so you will got the direction of positive and direction of negative. Okay, and when you want to find the middle one is RO. Okay, this one is that you want to find to set that in visualization what the direction of electric go. Okay, it will show. Okay, and IQP is this one, because if you want the direction of negative, you have to give RO minus by IQP. Okay, and IQP is S over 2. Why S over 2? Because this one, right? Because it's separate in the middle. Okay, and next, then you find E plus or E positive and E negative, and find the main one is the E. Okay, you have to find this one to plot to you to show in positive and you to plot the graph. Okay. Okay, and how to find RO? This one, the main one that we want. Okay, RO 5 by this one. If you compare with the theta, because theta is used in circle, right? So the circle, the direction of the RO is a radians. This one. And in radians, in one this, you have to make the in x-axis and y-axis to find the middle one, right? Okay. In x-axis is a cos, in y-axis is sine. So you will got RO 5 by R cos theta and R sin theta, that is x and y and z. Okay, and if you set the theta start from 0, you will find that in next theta 5 by 2 pi over n. Okay, and what is n? N is the the number you set that how many line you need in every how many lines you need in the visualization or in lab? In every zeta. Okay, so let's get into the code. Okay, this one is a set graph, don't worry. Okay, K. What is K? Okay, I forgot to tell you. K is the 1 over 4 pi epsilon naught is the constant. You have to remember this one. 9 times pi 10 power 9. Okay, as you can see. And Q is the charge. Okay, you don't have to worry, but I set it in 1 nanocoulomb, so it's 1 times by 10 power minus 9. Okay, and S is 1 centimeter. I set it to. It means S equal to. Yeah. Okay, this one. Okay. And we set the sphere to represent the charge in dipole in negative and in positive. Yeah, the position that I already told that s over 2, right? This one s over 2 minus s over 2. This one s over 2. Okay, and radian, and you can set anything you want and set the color. Okay, so the blue represent the negative, red represent the positive. Okay, and before we go to next ones, you have to set, because computer don't know, right? N is negative or P is positive. You have to set Qn dot Q is equal to minus Q. Okay, set the negative, set the positive. Okay, and radius, anything you want. Let's you can try anything you want. Okay, and theta angle is 0. And is you have to set to 0 first, and n at this one, right? I already told. N is talk about how many direction or electric that you want, right? So next one, the data equal to 2 pi. So okay, it's I already told that again in theory. And its scale, this one used to set that scale of how can I say, scale of arrow, or scale of the direction of electric. Oh, I forgot to tell you, arrow I used to represent the direction of electric. Okay, let's go calculate the loop. Use y in vertical. Y is in vertical first. I use it in vertical first. Vertical, if we want to show in vertical, what vector that you need to show, right? Okay, I will write it for you. Okay, in vertical you have to set x and y, right? And if you want to show in horizontal, this one, you don't need to y-axis, you need x and z, because it will go like this. This is vertical is equal like this. Okay, so set the RO that we have to find, right? This one, I call R sine, and RP equal to RO, this one, like this. So in the theory, and this one is the formula from this, and the main one is give the positive and negative addition. Okay, and use the E arrow to represent the direction of position. Okay, direction of electric, and theta will more and more. Okay, then we explain if you want to show, and then plot the graph for magnitude of E and theta. Okay, do the same thing in this one, but if you want to show horizontal, I already told that use x-axis and x-axis, right? and z, x and z. This one. Okay, and do the same thing. So if like this, is will have the electric value that is the same, right? Okay, we will see in the graph again. Okay, so I set the graph. Okay, everything correct. Okay, this one. As you can see in the vertical, and horizontal. I represent that blue one is a negative, red one is a positive, right? So it will say like this. The electric direction that from positive move out and go forward to the negative. So the direction go out from the red one to the blue one, right? As you can see, go and go to the blue one. In horizontal, go the red one, go out and go to the blue one. Okay, it is set in theory. So see the graph. You don't have to worry about the vertical and horizontal because it have the same value electric. Okay. Okay, and if you tell that the electric of value value of shot is one, right? 10 power minus 19 coulomb, so it's so many rays, right? So and how I said, right? You may ask how I said, because if you said this one is 2 rays, you can see it don't show any electric. So that's why I set the E scale. If the chart is 2 rays, you have to set new E scale to big one. Maybe T times 10 power 2. That's okay. It's too big. Yes, look good. Or maybe too small. Maybe one is good. Yeah. Okay, so I will conclude about the electric field in dipole. So you can see the electric will go out for positive charge to the negative, okay? And E, if you want the main one that you have to show, you have to set positive and negative and plus to find the main one. Okay, so this is my project, and thank you very much. Bye bye.